How many of you are using IntelliJ? It's like, okay, it might be easier to ask who is not using IntelliJ. It's okay. All right. How often you have to debug? Once a week. More than once a week. Every day. Why, people? Why are you doing it? Don't you write unit tests? Yeah, my personal opinion is that debugger doesn't make you productive. It's much more efficient not to get into the need when you have to debug something, right? But there are situations when you have no choice. You either need to debug an issue that is already in production and you don't know how the code works. It was written by some other people ages ago. It's a legacy, but you need to fix it. You don't know the requirements, why it works this way, why it's the code is doing the thing it does. So my goal today is not to convince you that you need to use the debugger. No. My goal today is that I'm going to show you a number of features in IntelliJ Debugger that might make your life easier tomorrow. So it's not exhaustive list of the features in IntelliJ for the debugger because the full content might take a few hours to go over and make up the use cases. Why would you need one feature or another? So I picked a few interesting features, and we will see how you can apply them in your work. And I hope that it will be useful for you. At least one of those will be useful tomorrow. And we'll do a quick show of hands at the end if you actually learn something for my pleasure. All right. What you can do with the debugger, or obviously you can debug things, but you can also analyze the code that is being executed. You can amend the code behavior at the runtime without restarting the application in various ways, either by using the embedded hot swap mechanics. Who have been using hot swap at least once? Not too many. Okay, I hope one first thing already will be useful for some of you. Besides that, you can change the code behavior to reproduce some of the issues in your application, and also you can analyze memory issues. Today, we are not getting into memory part of the debugger. It will be mostly about the behavior of the application and what features the debugger in IntelliJ provides you, to efficiently work with those use cases. So, first, very simple stuff. We're going to see how you can change the behavior of the program at runtime. The very obvious feature that is provided by the runtime is the hot swap feature. So some of you already know what it is. Let's check the code. We have a main method. Sorry, like this. We have a main method that executes something in a loop. Like let's start it, and we'll see it just prints a line concatenated from a few numbers. Let's run it. Oh, yeah. So it runs. Without setting a breakpoint, we can just change the code and recompile it and see how it changes. For instance, I don't want to concatenate 10 numbers. I can just change the loop boundary, recompile the code, and once the code is recompiled, the IDE detects that there is an updated timestamp for the class that is compiled somewhere in the file system and offers you, hey, do you want to trigger the process of sending the new bytes into the runtime? If we are doing very little change, we will see that it succeeds. So we can see that now the printed line is slightly different. But if we try to do more than just changing something inside a body of the method, let's say we do some refactoring, extract a new method and recompile the code. And the IDE again asks to send the bytes. It will not succeed. The runtime fails. So that's the limitation of the runtime. It's not the limitation of the IDE. IDE is just the client for the runtime to send the bytes, detect the events, execute the commands, and so on. Basically, there is a protocol, right? Whenever you run your application locally or remotely, it's basically the same protocol. And there is when you start the application, you probably have seen in the command line. Let's quickly start it with a debugger, with a breakpoint. Oh, sorry, it should be the debug action. Boom, and when it starts, you can actually see what it prints into the standard output. You can see there is an agent lib with a few parameters that mean something to you. Do you know what those parameters are? Not much. So, like, the first parameters don't make much sense to you, but the others, like suspend yes and suspend no, are the interesting ones. For instance, if you are debugging some remote process and you need to figure out what is happening on the startup, you can change this parameter, for instance, to n, to no, and the process will not proceed until you actually connect with the debugger. That's useful in the remote debugging scenario, for instance. So generally, people don't change those parameters when they debug locally, and that will be our main kind of use case today. So I will not be running remote debugger for the time's sake. Okay, what else could we do besides hot swapping? For instance, there is a way to run some statements in the debugger. You know about expression evaluation? Nice. Let's see that. So we are already at the breakpoint. The breakpoint is here. Let's do it again. So there is like, I execute a few loops and so on. What kind of things we can change here? For instance, when I want to change the logic that concatenates the string somehow, let's proceed there. And if I execute this block of code a few times, you can see that the I and the builder value are changing, right? So we can observe the state of different variables right in the editor without actually going to the special tool windows. And those are mutable variables in our program. So what we can do with expression evaluator is to evaluate some expression. For instance, if I set I to 0 and run the expression, it kind of resets the loop, and as a result, my program will print something else, right? So this kind of things, without actually changing the code, we are changing application behavior by changing the state of the variables and forcing some other values than otherwise would be calculated. Lets us experiment with the application that we want to analyze, how it behaves. And there are other features that allow us to do that. So for instance, the same feature, expression evaluator, you probably, it's somewhat hidden feature in the evaluation. You can expand it to not only run a single expression, but a whole code snippet. So virtually you can put a script here, bring out. hello, do something like I10, I don't know, and make up any logic here, and run the evaluation and change the program behavior. So for me, when I used to work in a product company that was building debuggers and profilers, it was the main tool for us to understand how some other framework is working and try to build hooks with a complicated logic. We were opening the debugger, inserting those code statements in there, and seeing how it changes, how the behavior changes, so that after we could take the fragment and put it into an instrumentation agent, so that for you it wouldn't be like you have to change your code somehow, but otherwise you just enable the agent in your application using the JVM option, and it just works out magically. So the instrumentation kicks in without having you to run the application in debug mode or anything like that. And this way, we could get the information from your application into the monitoring tool, and you get the value. Right. The other interesting way to change the behavior is to force the exit from a method with some value or with some side effect. So for instance, if we stop on the breakpoint right here, and we know that this is the method that returns the concatenated string, but imagine I want to change the returning value somehow, and maybe I'm not even in control of the source code. Maybe it's the library code that I'm debugging, and I want to see what happens if I change the library behavior somehow that I cannot trigger from the outside. I mean, I don't know which values I should provide for this method to return something interesting, to validate if my application would be stable or behave correctly after this method returns. I could do something like force return and say, please return me some other string, query, instead of numbers. And the application will print query, right? And the same kind of similar mechanics I can reproduce by forcing some exception to be thrown from the code, like throw exception, let's say new IO exception, test, like this. Right? Can you see it well? Yep. So if I run this, the uncalled exception handler kicks in. If I let the application run, I can see that the application crashed. Right? So this way, by changing and affecting the state of the application, I can experiment with my application behavior and explore what could happen if something goes wrong. Let's do a first show of hands. How many of you learned at least one thing? Nice. We are down here. So let's go for the second feature. Lambdas. How many of you are using lambdas in Java? Everybody, right? So they came in 2014, and of course the debugger was there before that. So it was a big work to support lambdas, especially on one line, because people started to use streams and put nice expressions in one-liner. And if you look at this expression right here, there is like 1, 2, 3, 4, 5, 6, 7, 8, 9 interesting invocations on one line. And when you try to set a breakpoint on such a line in IntelliJ, it would actually ask you, would it? It should. Okay. Yeah. So it would actually ask you where do you want to set the breakpoint, on a full line, on an individual lambda expression, and so on. So for instance, if I choose to set the breakpoint to the first lambda expression right here, if I go back and zoom out, it's highlighted right now. And if I run the application in a debug mode, obviously I should hit this lambda expression and, well, see and explore where it was called and so on. I want to show you here a few steps of analyzing this kind of expression. So this is the most, let's say, tedious and complicated one. So if I wanted to debug this kind of stream chain, lambda by lambda, if I stop in the first one, in the first expression, I want to proceed further, I can actually say that, hey, I'm now interested in running into the second one. How do I do that? I can say that run to cursor, this, Alt F9. So, and it stops in the next expression, or in whatever expression I set the cursor in. However, it's not the most efficient way of doing it. I think only if you want to, so you can, but you don't have to. You can do it more efficiently. Let's restart the application and set the breakpoint on the full line instead. Sorry, yeah. So we hit the breakpoint at the line, and currently we haven't specified at which expression we want to stop. And in IntelliJ, there are some other interesting actions besides run to cursor. There is a step into, and specifically the smart step into, which is now kind of a default for stepping. Because if you do a normal step into the function, IntelliJ will detect that, hey, at that line, there are quite a few expressions where you can go into and suggest you to choose one of them. Like, and you can do like select any of them by pressing tabs and just, you know, go somewhere. Let's say I want to check how print line works, and I go there. Boom. But it's still not the most efficient way to debug your stream chains. And in IntelliJ, there is a way to do that a bit more efficiently. For instance, when I run the application and hit the breakpoint, stop and rerun, I can choose to trace the current stream chain right here. That's kind of a bit hidden action. How many of you knew about it? Not too many, so the others learned something again. So if you run it, you will see the whole logic, the whole pipeline, how it transforms from one step to another. Currently, I'm working with strings, or it's pretty easy with primitives. If you want to work with some custom objects, for them to be rendered properly in this view, you need either a good toString method, or you need to customize a renderer. So in IntelliJ, for the objects, you can create your own renderer, own rules, how this should be, you know, rendered in all the debug views, including the stream trace view. All right. By the way, the renderers, let's see. Okay, I'm going to skip that one because we have to save some time. So let's go further. Method breakpoints. Everybody knows about breakpoints. Everybody probably knows about method breakpoints, and I hope everybody knows that method breakpoints are generally very slow. So if you set a method breakpoint, your application slows down very much because it goes into interpreted mode, and you will have to wait if your application is doing a lot of things, you will have to wait until your breakpoint finally hits. In IntelliJ, the method breakpoints are emulated. So they are not the real method breakpoints for the sake of performance. They are actually set on the first line. So it's kind of emulated on the first line of the method that we are trying to debug. And those kind of breakpoints are very useful if you want to explore the interfaces and the invocation of the methods from the interfaces. So here's a very simple example. We have a base interface that is implemented in 2 places, somewhere, literally somewhere, because we don't care right now. And as you can see, if I set the breakpoint on the bool method, I can run the debugger, and whenever the bool method from the implementation is invoked, the breakpoint will hit and say, okay, I'm calling this bool method which matches the interface, right? I have set only the breakpoint right here, but now IntelliJ automatically created the breakpoint here because the method was invoked. That's cool, but is it very useful to be used this way? Because normally, if you didn't even know about the breakpoints, you know that you can set a breakpoint at this line. Don't set the method breakpoint. Hit this line here in the debugger and do a step into. So pretty easy workflow. Don't know which one is more efficient, but usually if you are not very advanced user and you don't know all the features of the debugger in your IDE, you probably will go the most naive and simplified way to do your work. Here, if we do the find usages on the bool, we can see that it's really used somewhere, and the IDE finds it. But the other function, foo, we are not invoking it anywhere, and the IDE, the static analysis of the IDE tells us that it's unused, it's never used. But what if we set a breakpoint right here and try to analyze? Usually there is a need for this, right? Why? You observe some behavior of the application that you know that this code is executing, but you don't see where is it executing, who is calling it. For instance, in our scenario right here, when I was, what was I? Yeah, like if I just run the application, not debug, but just run it, I can see a string printed out, hello, from somewhere. And if I check the implementation of the class that I was invoking, the bool method, right? I don't see this line printed anywhere. So if I search the code for the string, I will find that something somewhere is printing the code, right? And the static analysis doesn't know that this function is actually being used. So if I run the debugger now, set the breakpoint here, and I see that it was invoked because, and why it hit, because we set the method breakpoint. And I can explore the stack trace right here and see, okay, someone is actually calling it via reflection. And in this very simple case, I specified the name of the method completely, right? I have a string foo there, so the ID search would actually find it. But since it's a string, it could be concatenated, it could be dynamic, we wouldn't know. So only in the debugger we can actually tell for sure that this function or this method was invoked from somewhere, because we can stop at the breakpoint and explore the stack trace. Good. All right, let me stop this example. So we learned about method breakpoints. Let's learn a bit more about the breakpoints. I think they are underused. There are so many cool options, and we can do a bit more interesting stuff with them. So, for instance, like if we set a breakpoint right here, just a few tips for you. If you have configured a breakpoint, not just by setting it, but you have configured some flags in here, and then you suddenly realize that, oh, that's the wrong place where I set the breakpoint. Now I have to disable it, put it somewhere else. You can do it much more easily just by dragging it into some other place, like this. Or if you hold Alt key, you can duplicate it into the other place, and so on. So I mentioned the options, and in this specific scenario, when why would it be interesting and useful? So let's run it. If we just let's say continue running, let's disable the breakpoint and observe the output first. So if we just run it, we see that the cache instance was created just one time. All the references are the same, right? But what if you need to check if how the object is initialized again and again and again, and you cannot change the code? So using the technique we have seen previously, we can go here and say, okay, let's stop at breakpoint and actually evaluate an expression and say that the instance is null. Because it's evaluate and log. So whatever code you write there, it could be a fragment, and the result of this fragment is logged into the console. So we could do anything with the state of the application right now, and just, run the debugger and remove the break. Sorry, it could be. Well, let's just execute it again, and we'll see that the output changes, right? So we see the different reference every time, but we have to do that every time. Like we have to hit the breakpoint every time. I would like it to happen automatically. How could I do that, or what do I need to achieve that? I would like this breakpoint behavior to exist, but I don't want to stop there. And it's possible to say that this breakpoint is not suspending one. So basically, you get all the behavior from the breakpoint, but you don't stop there. And we proceed with running the application, and we will see that, it proceeded and it did the thing. Or we can play with some other things, like, for instance, we could do a pass count until like some count condition is fulfilled. Let's say we want to pass 3 times and then enable the logic of the breakpoint. And then, for instance, in some other place, I want to configure some other breakpoint that depends on the first one. For instance, I want to enable this new breakpoint. Let me check the line. It's not visible. 210. 210, where is it? Sorry? Oh, yeah, it should be 202. And leave it enabled. And for instance, run in the debug mode again. So we enabled the new breakpoint. It's a new dependent breakpoint, but the previous one is triggering only if the count is hit, right? So we hit the condition, we enable the breakpoint. Now the breakpoint was enabled, so the condition is fulfilled that it hit, and now the second one triggers again. So it allows us to create pretty complex workflows for debugging your complex application logic. And where it could be useful is when you have branching, for instance, in your application. Let me show you an example here. So here's a very complex workflow. You have some data coming in into your application. You start processing it, passing it as a parameter to some other methods and so on. And then at the end, you hit some method that should do something with it. But you only are interested in one branch of this processing logic. For instance, you can set the breakpoint when your final branch is invoked in, from this step, not from the previous one. Set the not suspending breakpoint and set the new dependent breakpoint right here, saying that once the previous one hits, I want to enable it. The time flies fast, so I wasn't even able to show you all the features, of course, but I hope those that I showed you today will help you analyzing your application tomorrow, and have fun.